Okay, give me a second. I am just opening my data set. So I think today is the second last day of this FDP. I'm going to discuss about the correlation and regression today. So firstly, I'll talk about regression, and then I'll come to the regression part, and then we'll see how we can use these two using the Excel. In the previous days, I think I explained you the what I think on a first day we have discussed about the descriptive statistics. Then I talked about the chi-square test on the same day. Then we have seen the various kinds of t-test, that is one sample and two samples t-test. After that, I discussed ANOVA. In that, we have seen two categories of ANOVA, one-way ANOVA and two-way ANOVA. Now, we'll talk about today the correlation and regression, right? So, I'll share my screen first. Give me a second. And then we'll discuss the conceptual aspect first. And then I'll move to the okay, I think I shared my screen. Is it visible or not?
Yes, it's visible.
Yeah. So I'll firstly talk about correlation. So I am writing in my Excel only, right? So I start with the definition part of correlation. I think from the name it is quite clear to us. Correlation means when we keep a core type of term in front of any particular word. Like here you can see correlation. So that means it is quite obvious that we are talking about at least two objects or persons or things, right? So that means when I talk about correlation, that indicates the relationship between two variables, right? So whenever we are interested to find the relationship between the variables, we need to generally talk about the correlation. And correlation is the very basic, or I can say it's a test which is providing grounds to so many other statistical tests. So that way I can say this is a basic requirement in statistics. Generally, we need to test between the variables the correlation, and then further we are going for the advanced statistical testing, right? So that is why you can say this is generally known as the basic block of the statistics. So that is why you need to understand the concept of correlation. Now, apart from the relationship, if I say, as I say that two variables are related or not. For example, if I say the prices of sugar, right, and the prices of suppose sweets, right, or the fare prices and the petrol prices. So that means it is quite obvious if I'm saying these two terms. So I think you can easily relate these things that yes, these two variables will have some linkages between them, right? So that way, one variable is making changes in other variable. So that way you can say this is known as the correlation, right? Now, if I say the purpose of correlation, so the main purpose of correlation is to find out the strength of the relationship. So to find out the strength of the relationship, we are using the correlation. And apart from that, if you want to know the direction of relationship, even then we are performing the correlation statistical test. So these are the two important parameters, that is the strength and the direction of the relationship. We want to know these two things. In that case, we are going for the correlation. Then generally, as I said, I have given a simple example to you that if fare prices are increasing, so if the petrol prices are increasing, so fare prices will increase, right? So that way we can say this thing that if fare prices are increasing, so they are impacting the prices of the petrol prices are increasing, so they are impacting the fare prices, right? So that way there is some correlation between these two variables. But the problem is in correlation is that it is not a causation. Correlation is not a causation. So it is not a causation. Means if you want to study cause and effect relationship between the two variables, in that case, correlation is not at all appropriate statistical test or tool. So correlation can never be a causation. Means correlation can only tell you that how strongly, moderately, or weakly two variables are related, in which direction they are moving. But correlation will never tell you that which variable is cause and which variable is effect variable. Means being a researcher, being a user, you know this thing that these two variables, this variable can be the cause and this can be the effect. But if you want to study how much impact you want to see in which, of one variable or other variable, that you cannot study using the correlation, right? I hope it is clear.
Yes, ma'am.
Yeah. Now I'll talk about types. So usually in statistics, those who are belonging to this particular type of field, maybe they are knowing this thing that there is variety of variety of correlation available in statistics. But here I'll broadly talk about only two types which you need to understand for understanding the concept of correlation. And these two are, give me a minute. I think my laptop has got hanging. I need to wait just a minute. So I think I'm discussing. Meanwhile, it is coming in a workable mode. So if I talk about types of correlation, so there are mainly two types of correlation. First one is the positive, and second one is the negative correlation. So it's a positive and negative correlation, right? Positive means when the change of direction is same. It is positive correlation, and when change of direction is opposite, it is negative correlation. So as I have given you the example of petrol price and the fare prices, so I think it is quite obvious. If petrol price will increase, so it will chance that the fare price will also be increased. So that means direction of change is same, right? So that way it is a kind of positive correlation. If I'm increasing one variable, other variable is also increasing. That is positive correlation. If I'm decreasing one variable, other variable is also decreasing. That is a kind of positive correlation. Negative direction of the change will be different. That is, sorry, change of the direction will be different. That means if I'm increasing one variable, other variable is decreasing. So it is a negative correlation. A very simple example to understand negative correlation is if you are increasing the prices. So we know the economics law says that demand will decrease of the product, right? So that way you can see if you're increasing the prices, demand of the product will decrease. It is a kind of negative correlation, right? So positive correlation generally it is denoted by the, just a minute, by the positive sign. That is plus sign. Then if I talk about negative correlation, this you can denote by the minus sign. So it is positive. If you are getting the positive value, that is a positive correlation. If you are getting the negative value, that is a negative correlation, right? Generally, bifurcation of strength of the correlation can be, you can call it as a strong correlation or moderate correlation or weak correlation, right? Then talking about how to measure, how you can measure the correlation. So method of measuring correlation is, generally the well-known name is available, which is the Carl Pearson's coefficient of correlation, right? So this method generally you can use to get the value of correlation, and this is denoted by the small alphabet, that is R. So using the R value, you can get the value of correlation, right? Oh, it is converting in this form. Just a minute. Right? So this way you can denote the coefficient of correlation R. Now for getting or applying the Karl-Pearson coefficient of correlation, generally you need to have which kind of variables? So requirement of variable. So here you need to have, I think I'm writing in the same line. That is to apply coefficient of to apply the Karl-Pearson's coefficient of correlation, you need to have continuous scale variable. Right? So the requirement of variables should be that variable should be continuous scale variables. Right? So if you're having the numeric variable that is continuous in nature, in that case you can apply Karl-Pearson's coefficient of correlation. Right? I hope till here I'm clear to everyone.
Yes, madam.
Fine.
Yes.
Now moving ahead, I think it is enough to understand the concept. Now how to perform correlation, that I'll show you afterwards. Firstly, I'm talking about the next concept, that is the regression, right? So regression is also telling you the relationship between the variable, but this correlation is giving us the value in terms of, I think one more thing I forgot to tell you, the range of R. So maybe I think you all are knowing it is -1 to +1, right? I think it is formula, so it will not take just a minute. Now it is okay, right? So the range of R is -1 to +1. I think it should be -1 and this. It can be -1 also, it can be +1 also. -1 R meaning is that there is a perfect negative correlation. +1 if you are getting for R, so you can say or you can conclude this thing that you are getting a perfect positive correlation, right? Now, generally, if your R value is in between 0.75 to 1, so it is a strong correlation. Between 0.5 to 0.7, generally it is known as moderate or average correlation. Below this point, below 0.5, generally it is known as weak correlation, right? So this is, I think I explained. Now coming to the regression part. So as I said, correlation is generally giving you the strength. That way, if you are getting, suppose the value of R is coming as suppose 80. So meaning of this is that there is a strong positive correlation, right? And in terms of percent, what you can call it as 88% correlation is existing between the two variables, right? So when you are expressing the relationship in terms of percent, that way correlation will help you out to get that. But if you want to express the relationship between the variables in terms of algebraic form, in that case, we are going for the regression. So the purpose of regression is generally to find the impact or influence of one variable on other. Then if you want to forecast a variable using other variable or variables, right? In that case, you are talking about the regression. This is also helping you to fit a model between variables. So these are the tasks of regression. I'm summarizing again. If you want to get an algebraic relationship, that is an equation form relationship, in that case you are using the regression. Or you want to find the impact or influence, or you want to see the effect of one variable on other, in that case you will go for regression. If you want to forecast your one variable using other variable, in that case you will go for regression. Or if you want to fit a model between the variables, in that case also we will go for regression, right? Now, talking about the types. So there are usually so many different types of regression available. Here I am talking about only two: simple linear, which is requiring two continuous scale variables. That is, one will be DB and second will be IV, dependent and independent. And next one is the multiple linear regression. So here we will be having more than two numeric variables.
Ma'am, can I ask a question?
Okay.
Now, suppose we are trying to predict if it is going to rain or not.
Sorry?
And we are going to predict if it is going to rain or not.
Hmm.
We have a couple of independent variables, temperature and humidity.
Hmm.
There might be others, wind velocity, etc. We're not worried about that. But
Hmm.
suppose we have temperature and humidity. Now, see, these two are kind of independent of each other, right? So
Hmm.
how do you calculate a correlation between two variables that are kind of independent of each other? Means I can understand there is a correlation whether it will rain or not based on the temperature, or whether it
I'm
is rain
not
or
getting,
not.
sir. I'm not getting. You want to calculate correlation or regression?
Correlation between regression, I understand we can find out, but I'm talking about correlation between temperature and humidity.
Hmm.
How do you calculate the correlation? Because see, when we uh, calculate the correlation and uh, come up with a heat map in Python and all those things,
Hmm.
we are calculating the correlation between the independent variables as well.
Hmm.
So when we call them independent, why are we coming up with a correlation factor? How are we coming up with that?
I'm not getting your question.
Madam, see what I'm saying. Suppose we are trying to predict
Hmm.
based on temperature and humidity
Hmm.
whether it is going to be raining or not. That is a
Hmm.
class of maybe logistic regression. Okay. Now the thing is, temperature and humidity
Hmm.
are independent of each other, right?
Hmm.
One will not have a bearing on the other.
Hmm.
Now, see, but when we plot a correlation coefficient graph or a
Hmm.
heat map or whatever it is in Python, you know,
Hmm.
this visualization tools or whatever,
Hmm.
how are we able to measure that temperature is 0.88 dependent on humidity, or temperature is 0.7 dependent on humidity? How are we able
I think
to?
your question is not logical, sir. I think it is, there is no base of your question. I'm not getting your question, because if you are talking about correlation, in that case, generally scatter plot we are plotting.
Okay.
Scatter plot is generally we are using to get the relationship between the two variables, right? So why we will go for heat map? Firstly, I'm not understanding that thing.
Excuse me,
And
ma'am.
that, yes.
I think I understood his question. I just want to interrupt. What he wants to say is, in correlation, we are going to find out the relationship between the variables.
Hmm.
In regression, we are going to find out the relationship again between the variables. But
Hmm.
what he's trying to say is कि in regression, his point is कि हमारे पास दो वेरिएबल्स हैं, एक टेम्परेचर और एक ह्यूमिडिटी है, वो दोनों आपस में इंडिपेंडेंट है. अब
Hmm.
जो दो वेरिएबल इंडिपेंडेंट है, क्या उनका कोरिलेशन निकाला जा सकता है? I think what I understood.
Yeah.
Francis, sir, this is what you are asking?
Yeah. Can we take a correlation? And if so, if there is a measure, how can we say this is temperature is so and so correlated to humidity?
Yes.
Sir, I think this is a very, what I can say, I think you should understand being a researcher if you're asking this question. This is like if you are putting some figures for applying of the correlation, right? Because the formula is like they are giving you the results. The formulas are not knowing this thing that you are whether you are passing the correct thing to the form in the formula or not, right? So that way you will get a correlation value. But being a researcher, this is your call whether you want to find these relationship or not. If you're understanding these two variables are independent, then why you will go and find the relationship between them?
Yeah, but see, there are certain cases in which there could be a correlation.
So that
Like,
is what I tell you. That is generally known as here. Well, when I talk about the regression, where you are getting the value of r square, right? So
yeah,
generally, when you are getting the value of r square, we are knowing this thing. Value of r square is indicating that as the variance explained by our independent variables for the dependent variable. But there also you can get one more value of r square, that is known as the adjusted r square, and that is a kind of value which is less than to your R square value. And generally the reason of getting that value less than from the R square value is that because might be possible your variables, that is independent variables, can be correlated, and it is quite possible. Because I think if I say suppose the yield of crop, right? So if I
right,
talk about, I want to see the impact on the yield of crop of so many other factors, like the quantity of the rainfall, then maybe the temperature, then the quality of seed or the fertilizer, etc. So many variables can affect the yield of the crop, right?
right,
So
right,
suppose I'm considering the four variables only, because I think it is not maybe beyond my study, and I don't want to consider other factors. But it is not like they will not impact my crop yield of crop, right?
right.
But still, suppose I'm considering the four variables, right?
Yeah,
And then if I'm finding the impact altogether, means I want to see the all four whether they are impacting my yield of crop or not. So again, the question is that might be possible few of your independent variables can be correlated, and that is why they are impacting, because they are moderating, or maybe you can say they are changing the relationship between the independent and dependent variables,
right.
right? So that is why in statistics there are certain measures available which will use as a fine or maybe penalty, and this will reduce your main value. So that way maybe your model is not a good fit or something like that. So according to your question, maybe if you're asking, so according to means my understanding, sir, because I think I'm not a very big expert or something, I can only say this thing, that if we are using two variables and if we are already knowing that there will be no correlation, suppose I am saying the sugar prices, right? And suppose the prices of salt or maybe any other commodity which is not at all linked with each other, right? And if still I'm finding the correlation between them, so might be possible I can get some value of correlation. But being a researcher, this will be my discretion that I should not go for this thing. This is what I think I can understand, right? If you are knowing priorly already that no literature is available which is saying that these two variables is having any linkages or having any relationship, then why we will go and find? And even if in a real world I am finding there is no linkage, I am finding. But sir, there can also be one more possibility here. I will say to you, there is a one more type of correlation which is known as spurious correlation. That spurious correlation is what means if two variables are not related and still you're getting some value, so might be possible there can be some third variable which is making the, or which is causing the relationship having in between these two variables. So that type of hidden variable can be available which can impacting or maybe making two variables to be correlated.
Okay, madam. I think others are getting disturbed. You go ahead with the class. Maybe towards the end we can continue. Okay,
Fine.
madam. Sorry about this. Yeah.
No, fine, totally fine. So I hope, I think I was on the multiple linear regression. So I was telling you, when you are having more than two numeric variables, right? In that case, you are going for the multiple linear correlation regression. In that case, one variable should be your dependent variable, and more than one independent variables you need to have to perform the multiple linear regression. So these were the types. Now talking about, as I said, you can fit a line generally using the regression, or you can say you can fit a model. So generally, in, as you can say, name is linear. So this is the straight line equation. I think in school mathematics we all have studied this particular equation, which is y equals to a plus bx, right? So y is what? Y is nothing but is your dependent variable or response variable, right? Then a is intercept B is flow, X is independent variable or predictor variable. So this way, if you are having the value of these two constants, A and B, you can put them in the equation, and then if you are putting any value of your independent variable, according to this particular right side, the value of the y, that is the dependent variable, will change. And that way you can predict your dependent variable using this particular equation, but provided you need to have the values of A and B. Is it clear? I
Yes,
hope.
ma'am.
Yes.
Yes, ma'am.
Yeah. Now, I think it is sufficient to talk about correlation and regression. Right. Now, I'll come to the same sheet. I have opened the first sheet, which is named as correlation. You can find here we are having the two variables listed. First one is the temperature. Second one is the sales of ice cream, right? So I think we know this thing that both the variables are numeric in nature, or you can call them as an these two variables are continuous in nature, right? So there are two ways to perform correlation or to get the value of correlation in the Excel. First thing is, suppose you are writing the equal sign, put a equal, and use the function CORREL, correl. You can see it is asking you to provide the array. So first array means first variable range is this, put a comma and provide the range of your second variable, right? And here the pairs should be, means your data should be in pair form. If in one variable you are having suppose 10 observations, in second variable if suppose you are having 12 observations, in that case you cannot perform correlation. So there should be a proper pairing between these two variables observations, right? I hope you have seen what I did. May I press and enter?
Yes, ma'am.
So you can see these are the values of, this is the value of R, right? Now, the value of R is what? It is greater than or
25.
0.75,
Yeah.
right? So that means I can say that the
Strong correlation.
strong positive correlation between sales of ice cream and temperature, right? So this is a strong positive correlation. That means if the temperature will increase, so it is a chance that the sales of ice cream will also increase, right? So there is a positive correlation. Clear to everyone? May I explain you the next way?
Yes, madam.
Yeah. So for that, you need to go to the data tab, click on the data tab, go to the data analysis toolpack. There you can find a correlation test is available. You need to select this correlation and click on the OK button. It is asking you to provide the range of your data. So you can provide the range of your data. I have given my range including the labels. Data is grouped in the columns. Labels are selected. So I'm selecting this checkbox. Now, output range is this. I'm giving the same sheet blank cell reference to provide the output to me. I think I'm all set to get the output. So may I click on OK?
Yes, ma'am.
Okay. So now you can see you are getting a table which is telling you about the correlation between the two variables, right? So you can find in the same variable, it is quite obvious the correlation value will be 1. Sales of ice cream and sales of ice cream, we are getting 1. But sales of ice cream and in temperature, we are getting the same value which we are getting here, right? So that way, these are the two ways of getting the value of correlation. Fine?
What
Is
did
it
we
clear?
pick, madam, in the data analysis thing? What did we pick? I'm sorry.
You need to go to the data analysis tab,
And correlation. Okay.
correlation, and then you need to pass the range.
Okay.
And I think rest of the things are very similar, which we have seen in the last sessions.
Got it. Thank you.
Okay, thank you, sir. I hope it is fine. May I proceed?
Yes, ma'am.
Next sheet is the practice sheet for all of you. You can do the practice. Go to the sheet 3 named as regression. Here we are having the data of COVID cases and the masks sold. So we all are aware of this particular situation when the COVID was pertaining in the all over the world. We were knowing this thing that the mask sold or the sale of mask was on the peak, right, at particular time period. So that way, in this particular data, suppose I'm having this particular data, so I want to fit a regression here. I want to see the impact of one variable on other variable. So can any one of you help me to identify which variable I can take as a dependent and which variable I can take as an independent here?
Ma'am, mask sold is dependent on COVID cases.
Very correct. So I can take here the hypothesis that there is no significant impact of COVID cases on the sales of mask. Right? Is it clear? Fine. So where I can write that the
Ma'am, your screen is not visible.
okay. Now,
Yes, ma'am.
yeah.
Thank you.
So now you can see I have written that there is no significant impact of COVID cases on the sales of masks, right? So that means I can say this thing that sales of mask is the dependent variable and COVID cases is the independent variable. So I'm having one dependent and one independent variable. I want to see the impact of COVID cases on the sales of masks, right? So it is very clear to us that we are going to perform the regression here, right? So now to perform regression, you need to go again in the data analysis toolpath under the data tab. Here you can scroll down and can locate the regression tool. Click on the OK button. I hope everyone has found it and on the same window where I am.
Yes, madam.
Yes.
Yeah.
So yeah, thank you, ma'am. So you can see in the first range, it is asking you to provide the range of your y variable. Give me a second. मम्मा सेशन में है शाम को लगा रहे हैं So you can see it is asking you to provide the range of your y variable. So you can select the mask sold which you have considered as your dependent variable, right? So y variable will be your dependent variable. X variable is your independent variable. So I'm selecting the range of the COVID cases here. Then now selecting the labels as I selected my data including the label. So I selected this. Fine.
Yes.
Okay, may I proceed? Yeah. Then constant is 0. You do not need to check this box. If you are checking this box that way, your line y equals to a plus bx. So a will be treated as 0, right? So that way you do not need to pass this or choose this. Confidence level, it is by default 95%. So I think I will go with this. Now output range is, I want to generate my output here in the same sheet. So I'm giving the range of the blank cell, and then coming down, it is asking you to calculate the residuals. Residuals are, I think I'll discuss just after the results, what is residuals. So for residuals, if you want to get something, you can select from here. So here you can select the residual plots and the normal probability plots. I think these two are sufficient for the regression to perform or to summarize. So you can select the residual plots and the normal probability plots. Done. May I click on OK?
Yes, yes.
Yes, ma'am.
Yes. Uh, just a minute. I think something, I made a mistake or something. Anyone who is getting the plots? Anyone?
Yes, ma'am. I got the plots.
Okay. Okay, I'm not getting, where is my plots? Oh,
Yes.
it was somewhere here. I don't know where these were. I have seen. I don't know where. Yes,
Yeah, right there, right there.
yes. I was thinking, where were these? What happens? Yes, fine. Okay. So I don't know why these are not coming in a single. They're coming back to back. These should be here. I don't know what is happening. I don't know what is happening in my case. We'll see. We'll see once I'll come to the interpretation part of those. So firstly, I'll talk about the output which we are getting here. Here you can see we are getting the R, multiple R. Generally, it is named in Excel. It is named as R, a multiple R. So it is the value of your R, which is 0.98. So if you can see, you two variables are mass sold and the COVID cases. In that, you can find the correlation value is what it is, 98%, right? So that is a high positive or the strong positive correlation between these two variables. Now talking about the value of R square, which is again a very high value, right? So generally this value should be greater than 0.6 generally, but here if I want to say, it is very large, very high R square value I'm getting, right? So I'm writing here the interpretation part of R square. So it explains variability or percent variance in DV corresponding to IB. So, or other way around if I say, or in the simple language if I say, so I can say it means 96 variance in mass sold is explained by COVID cases. Then I hope it is visible to everyone. So how much of your independent variable is explained by your independent variable? That type of study we can do using the R square. Somewhere it is telling you the fitness of your model, whether your model is a good model or not, right? So that you can can check using the R-square also. But the main work of R-square is to explain the variance, percent variance in the dB corresponding to your independent value, right? Now, adjusted R-square, generally you do not need to report in case of simple linear regression. When you are having only a single independent variable, generally we are not reporting this. But if you are having more than one independent variable, in that case you will go and report your adjusted R square and not your R square, right? So here we are striking off this adjusted R square and we are not discussing it, right? Then standard error is coming as 141.848. Observations were 12. Now the next table is the ANOVA table. In this table, you need to see the significant value of your ANOVA, that is of your F value. So which is 2.4 E minus 0. It means it is again a less than 0.05. So that means you can conclude here that your model is a good fit. Means your model is a good model. This is the conclusion we can draw using the ANOVA significant value, right? Now the last table, which is the important table to formulate your model, you can find here the coefficients values are coming here. Intercept value is both the A and B values you can find from the coefficient column. So A, that is intercept, it was -2, it is -245, 45.63, and your COVID cases are 0.99. Means COVID cases coefficient, that is B, is 0.99. But you need to check whether these two are significantly contributing to your dependent variable or not. So for that, we will check the p-value further. These are the p-value generated from the p-value, right? So p-values are both, either the first or the second. Both are less than 0.05. So what you can conclude? You can conclude that your model is a good fit, right? That your model is a good fit. Sorry, your your intercept and the coefficient of the independent variable both are contributing significantly to your dependent variable, right? So A and B, intercept is A, this was your A, and this was your B. So both the constant values are significantly contributing to your model, right? And what will be your model? Your model will be mask sold is equals to -245.63 plus 0.99 into COVID cases. So now if you are having the number of COVID cases for a particular month, you can put the value here. You can solve this particular equation and you can predict the sales of the mask, that how many masks can be sold if COVID cases are this, right? So this way you can make prediction. Now coming to the residual status, so you can see what is residual. I think every one of you knowing this thing. Residuals are nothing but this is the actual minus predicted value. So we all know whatever we are predicting, it is not necessary that that will happen or that will happen with the same magnitude, whatever you are saying. So suppose I am saying that the mask sold will be 10,000 in a particular month, or maybe 1 lakh in a particular month, right? So in that case, it is not necessary for a particular month, whatever I am predicting, it will happen. Chances are there. Error terms are always present. So many factors are prevailing in the market or in the environment. So maybe whatever prediction you are making, there can be some changes. So actual value and predicted value may or may differ also, right? So that means that difference is known as the residual or the error term, right? So for the purpose, we have plotted two graphs. I don't know where were they. Again, I need to fly or what? Anyone can see where are my graphs? I'm not getting them.
above your tables?
Sorry?
Is it directly above your table somewhere?
No, it is not there, sir. I'm trying to locate them, but I'm unable to. I don't know where were they. No issues. I'll apply one more time.
Exercise.
Okay, just a minute. Now it is fine. Okay. Visible to everyone? I hope visible.
Yes, ma'am.
Yeah.
Yes, ma'am.
Now you can see these two graphs which we are getting generally, as I have told this thing to every one of you, there are certain assumptions generally in each and every statistical test we are talking about, right? So in regression also there are certain assumptions, and few assumptions are related to your residuals, right? So you need to check that your residual should be normally distributed. So that way you can see this is nothing but this is the distribution of the residual values, right? So whether this distribution is normally distributed or not, that you need to check. This is the first thing, right? So somewhere you can see, you can find this thing that your probability value, probability plot is indicating if these are going in a trend line, in a what I can say, in a upward something it is showing, and without deviation, much deviation. If there are so many deviation, means these data points are not following a particular path, right? So that way you can call your residuals are not normally distributed. But here you can find they are following a particular path, right? They are not deviating here and there. If they are scattered here and there, in that case you can call that your residuals are not normally distributed. This is the first graph I explained you. Talking about the second graph, this graph is the residual plot. This residual plot is very important to understand. Here it is indicating the variance in the residuals, right? So this variance should be, whether it is constant or not, that you can understand using this particular graph. Here you can see if your residuals are forming any particular shape. In that case, means they should not form any particular shape. Maybe a shape can be like a cone shape. Cone shape means, suppose you can find that they are scattered, like they are forming a scatter. I think you all have seen a funnel. When I putting a funnel in a horizontal form, you can see this thing that is a kind of fan type of shape you can find, or funnel is like something like this, right? So if your data points, residual points are forming any particular shape, that is not correct. So for the variance point of view, so right above or below this particular line, so that is a middle line which you can find here. So if your data points are falling scattered here and there, but they are not forming any shape, that means there is this is a good sign for your residuals. Is it clear? So for normality plot, your residuals should follow a straight line kind of thing. They should not be scattered here and there. But in case of variance, these should not form any particular shape. These should not means these should not be in a particular shape form. If they are in a particular shape, maybe cone shape or fan shape, anything like that, in that case generally you can say it is not a good sign for your residuals. So that way your model is not a good model, right? So these are the two assumptions which you can check using the graphs in the Excel. Is it clear to everyone?
Yes, ma'am.
Yes.
Yeah. Now,
Yeah, madam, just one query. So since there is a normal, it is a normal graph, it comes with this kind of shape. So where it is distributed almost equally and it is not concentrated in any specific shape or what. So is there any relationship between these two graphs?
where, ma'am? In which two graphs?
This normal probability plot
Huh?
and COVID cases residual plot. As you said, in the
Huh?
residue plot, it should not form any shape
Oh.
or
Huh.
any particular shape. Now
Hmm.
here it is are upwards and it is distributed in this manner.
Hmm.
So
Hmm.
since this below plot, it is normally normal probability.
Huh.
So these two are related with each other or what? So because
No,
of this, the
I think
residue
you can
comes
see,
in this
ma'am,
way.
you can see their axis. Axis of both the graphs is different.
Right, right.
So they are not normal probability plot. If you will see on x-axis, your residuals are there, and y-axis
Right.
you can find the percent values are given, right?
Right,
But
right,
when you
right.
talk about the first graph, that is, I was talking about the
Residue.
value. Means
Right.
from the model, whatever values you are predicting for your dependent value. So those fitted value you can find, and on the y-axis you can find your residuals. So there is no relationship between these two graphs.
One is in correlation, one variable was discrete and another was continuous. Temperature is continuous and number of ice creams sold is discrete. So can we have a correlation?
Just a minute. I think I have given you the sales of ice cream, not the number of ice cream sold. But still,
Okay.
in discrete variable also, there can be a possibility you can perform the Carl-Pearson coefficient of correlation. But when your variables is of the ordinal scale level, in that case, you can you need to go for this.
Is it showing autocorrelation?
Which graph, man?
Autocorrelation?
Which graph?
Not the normality, another COVID, that S type, no? COVID.
This variance graph?
Uh,
This is showing you what?
Autocorrelation?
Autocorrelation. No, it is talking about the variance.
Like there is an S kind of a pattern. Horizontal. Yeah.
Yes.
Correct. It's a time series data.
But I think, but this data
Here
is
it is.
not time series data.
Okay. Okay.
So autocorrelation, we are talking in terms of time series, I guess.
Yes.
I think, ma'am, in Excel, there is no formula or function dedicated. You need to calculate that manually.
Okay.
There is no function available or not, no process in the data and school pack is all checked.
Then minus R2 and the D square, we have to do ourselves.
Sorry, ma'am?
Our ranks difference and D square, we have to.
Do we have, ma'am? Have you applied any time?
No, ma'am, I have not applied for master's.
Just a minute. I am doing one experiment and we'll check. I think this can give correlation value, correlation function can give you that, because ranks are also will be some numbers.
Madam, your screen is not visible.
Oh, sorry, sir. Give me a second. I'm just sharing. I'm just performing correlation. I'll try if it works. Maybe I think it will work for using the same function. Give me a second. Let me share my screen. Okay. I think I have written here the rank values. You can find. Right?
Yes, ma'am.
So I have used the simple correl function, that is correlation function, and I applied for pass the ranges of these two, and I'm getting the value of R. So because I think correl is a function, but only the mechanism is different, because that correl is dedicated for on the basis of Carl-Pearson coefficient or correlation formula. So you need to check firstly manually whether you are getting the same rank value, Spearman rank value. If yes, in that case you can apply using this also. But I need to check, I think, once. Otherwise, no dedicated formula I have found till now.
Okay, ma'am. Thank you.
Okay.
Ma'am, can you please explain when to use Spearman and when to use Carl-Pearson?
When you are having the ordinal scale variable, because I think in name itself you can find Spearman's rank correlation. Ordinal data is ranked data. So if you are having ranked data available, if you have asked your suppose I think in my statistics I have studied a very good example, which I think I can recall today also. That is, if I'm asking two judges of the beauty contest are sitting and giving the ranks to the participants, right? So that we are having the ranks of two judges, and you want to see that how much closeness in their approach or in their means what I can say thinking process for giving or for judging the beauty of the participants, right? So that way you can apply there the Spearman's rank when you are having the rank data available with you. But if I talk about Pearson's coefficient of correlation, in that case you need to have your continuous scale data, that is numeric or discrete data you need to have.
Okay.
Madam,
Can you write
Yes, sir.
regression equation for the same example? Ma'am, can you write
Sorry.
regression equation example? Ma'am, can you write regression equation for the same example? Regression equation.
Tarun, your voice is not very audible.
Hello, I'm not audible.
No, Tarun is trying to
It
speak.
even
His voice was not
I
audible.
even I have
Ma'am, can you? Am I audible?
sir not
Am I?
clearly.
Ma'am, can you write regression equation for same example? Regression equation.
For which question example you are asking, sir?
Ma'am, you explain regression, and for the same example, can you write regression
Sir,
equation?
for which example you are asking about? The judges you are asking about?
Yeah, COVID cases and mask.
Okay, okay. I think I have written this. Just a minute. This is written here, sir. I hope visible to you.
Ma'am, in terms of A and B, so that we generate a regression equation for another cases also. Generalize the equation because
I'm not
after
getting you.
correlation. Ma'am,
I'm not getting
when you calculate, ma'am, after correlation and regression, we give regression equation for generalize the data, generalize the
This
equation
is
so
the
that
equation.
anyone can calculate.
Tarun sir, this is the equation. What is the problem here? You need to only put the COVID cases here and you can predict the mass sold. What is the problem here? This is the equation.
And
Are you
in the
getting?
marks, yes, ma'am, yes, ma'am.
Chanchala, madam. See,
Minus,
yeah, go ahead. Tarun, go ahead.
got, ma'am, got your point, ma'am. Thank you.
So, see, this equation is going to give us a straight line, right? This y equals mx plus c type. So here, see, the intercept is minus 245.63. So now, why can't we plot this? Why have we not? Where can we plot this in the data analytics thing? The different correlation and all those options are there, right? If I want to plot a graph for mask sold equals minus 245.63 plus 0.9 into COVID cases. So I need to plot a graph for that. So where do I plot that? How do I plot that?
Sir, just a minute.
This is very similar to the below graph we had plotted.
No, it is different, sir. It is not that. Uh, just a minute. I need to decrease its size to bring it down. Yes.
how did you generate the best fit line automatically?
So it is generated. You can see. I think softwares are available. You can find. This is there, right?
Right. Yeah. So this is a case of simple linear regression.
Hmm.
Talk about little multiple linear regression.
Multiple.
Huh.
Hmm.
The doubt I was asking.
Hmm.
Suppose there are. Suppose we are talking about the rent of a house
Hmm.
based on a couple of factors like the number of rooms in the house and the square footage of the house.
Hmm.
Okay. So the number of rooms and square footage have a positive correlation, right?
Hmm.
But there might be other independent factors while deciding the rent of the house,
Hmm.
which may not be very correlated with each other. But for all those independent variables, when you plot the heat map,
Hmm.
we get certain values, isn't it?
Hmm.
So the why do we call those independent variables and try to find a correlation? That is what my question was.
Sir, I think as I said initially, whenever we are talking about these, what I can say, statistics. So generally, correlation is the building block, right? First
Huh.
thing. Second thing, if you are saying is, you are saying that you are plotting a heat map for all the independent variables. This is what you are saying, right?
Right.
Right. So as I said,
Independent as well as dependent, put everything together.
Yeah.
All the x's and the y, we put everything together and plot the correlation coefficient, that heat
actually,
map
sir,
thing.
you
Yeah.
need to check, as per my understanding, you need to check whether the independent variables are having high correlation or not. If they are in itself, they are having a high correlation. So that way, there is a problem in the relationship between the dependent and independent. So that is why the relationship between your independent variables should be very minimal.
Right.
Because if they are correlated to each other, in that case, the main correlation or the main relationship which you are which you want to find between the dependent and independent, there will be a problem.
So we basically have to pick those variables which are not highly independent variables, which are not
Huge
highly
value.
correlated to each other.
Obviously, sir. Otherwise,
So
sir, just a minute. Otherwise, if you are performing with that data, in that case, your R square will go down. ANOVA variable will also be not good. The F and significant value will also be not good. In that case, your total model, final model will also be not the fit model. So
right.
if you are if you are predicting your dependent variable using such kind of model, that will not give you a good result. So that means you can say there will be high errors, chances will be there if you are predicting whatever.
Right. So that those independent variables which are highly correlated, we call them collinear, is it? Collinearity, something like that?
Multi-collinearity.
Multicollinear, correct. Now, see, the other thing was, see, we are performing simple linear regression with our COVID cases and number of masks. So why are we coming up with a hypothesis? We can just plot a regression, we can come up with a regression equation and we can make some intuition based on that. Why are we always trying to start from the hypothesis?
Sir, I think statistics is all about hypothesis. You need to check, as you can say, value is, suppose you are getting intercept value, you are getting the coefficient of your independent value also you are getting, but those values are significant or not, that is also important to check. No, if they are not significant, still you are using them, you are predicting the values of your that particular y value, that is dependent values. In that case, your model will not be a good fit. That is why these statistics tools were developed for us, so that we can check their fitness beforehand before concluding anything. So this is the purpose generally of statistics. But still, it is because it is not totally. I'm talking in context to the research point of view. In research, generally we are following such practices. But still, if you are go in the industries and all, there you are not formulating the hypothesis, but still you are checking there is a significant relationship existing between the variables or not. So in that case, maybe you are not on paper you are writing anything, but still
Correct.
the purpose is same.
Yeah. So as long as we get a high correlation coefficient between the independent and dependent, so that serves my purpose. I do not have to go for the hypothesis, is what I'm trying to say. Anyway, you answered my question. Yeah.
Yeah, means that if you are talking in terms of your business or something, but if you're submitting your work in any journal or somewhere else, in that case, sir, you need to write all these things, right? But if you are talking in terms of your businesses or industry or somewhere, in that case, being you, that will be the call of the businessman or of the particular person or manager or something.
Right. And what is the point of plotting the residuals? See, residuals are basically the differences between the predicted and actual and predicted. So what is the point of plotting the residuals and trying to find out the how the distribution is and all that? Is it a funnel, horizontal funnel, or whatever it is? Why are we trying to do that? What are we trying to achieve?
Means here, if I talk about, as I think I have talked about that first graph, normal probability graph, right?
Right.
So, hello.
Yes, I got you. Yes.
Yeah. Because residuals are nothing but these are the differences of your actual and predicted value, right? So if these values are related to each, main thing means whatever I studied in the statistics to find a sound model or a good model, your this residual should be normally distributed and they should follow a constant variance. This is what I studied. If they are having the high variances, that means again your model is not a good model. And if they are not normally distributed, again your model is not a good model.
Okay. So basically, when the variance is high, means deviation from the predicted values is high.
Here we cannot say from mean, but here we can say yes. The deviation is very high in means whatever predicted values we are giving using the model. So that means variation high is that means model is not a good model.
Yeah, it's not a best fit line then. The line that we're getting is not a best fit line.
Yes.
We have to strive to get a better fit line.
Better fit line.
Yeah. Okay, madam. Thank you. Yeah.
Thank you, sir.
Ma'am, in continuation with this, see, in a regression output, we have so many figures like output we have. So what to write in the interpretation when we are presenting somewhere the research and we have
to report the value of R type of test you are performing, right? If multiple regression, you will go for adjusted R square. If the simple linear regression, you will go for the R square value. After that, you will report just a minute, I need to check my output. F value is given, I think, after that, right? So after that, you need to report the F. F and significant value you need to report. And then
what it is saying here, same the result like that we were writing in the ANOVA?
Telling you the fitness of your model. Generally, it tests the linearity that your model is a good fit or not, that we are concluding using the ANOVA value. F value, the intercept, T value, and its P value.
Okay.
And if you want, you can also give the confidence interval percentage, that 95%, up to you.
In this example, we consider our variables are
Everyone are not audible to me. Everyone are not audible.
Am I audible?
Anyone can hear, sir?
Tarun, you are not very audible. Tarun, sir, you are not very audible.
Am I audible, sir?
Yeah, better, slightly better.
Yes.
Okay, ma'am, we consider our variables are linearly correlated, but sometimes it is not possible. Maybe parabolic correlated or sigmoid S-shape correlation. So how before analysis, how we interpret this correlation is better. Means we always consider linear correlation or some other relation like parabolic correlation. How we judge by seeing the data. Got my point?
Sorry?
Ma'am, before analysis, how we will interpret our variables are linearly related or parabolic related or some other shape related.
Sir, usually scatter plot we are using to check the linear correlation between the variables. So you can plot.
If any other correlation between the variables, how we will check?
For that, I need to check, sir. Even I haven't done that type of practices.
See, in this case, madam, what Tarun
Yeah,
is
sir
saying.
is available with us.
No, what I'm saying, see the relation between number of cases and the masks sold. See, when we do a scatter plot, like madam was saying, if we can kind of see that there is some kind of a straight line we could fit, then we could go with the linear. If there is, for instance, it is not fitting or it is not going into a straight line manner, then probably we will have to go into parabolic, based on how you train the model and all those things. It goes and jumps into a little bit parabolic. If it is an underfit model, it tries to adjust itself and goes into parabolic. When I talk about Python or other things, but here I don't know Excel may, how will we actually figure out? So we try to fit the points on a straight line in the beginning. If it fails, if it is not a good fit, then we try some other fit.
Regression.
Yeah, maybe it is a parabola, maybe it is S shape, maybe it is even a polynomial. Who knows? If it is trying to overfit the data,
Right.
it could go into polynomial also. You know,
Yes. Yes.
so yeah.
Okay, fine. Thank you so much, Francis, sir, for your knowledge and experience sharing with us. Thank you so much. I think this is all from my side. We will meet for the last session tomorrow, and there we will discuss. Means I'll show you certain cases or case-led, I must say, situations, and there we will discuss that in that situation which test is appropriate to perform. Right. So thank you, everyone. Good night. Take care. We'll meet tomorrow.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you, sir. Yoga, sir, we are done for the day. Thank you.